Welcome to the Explainer. If you've been building with AI lately, you've probably hit that wall. Making the leap from a basic, chatty AI assistant to deploying a truly autonomous, long-running agentic workflow, it's a massive challenge. Suddenly, we aren't just dealing with generating text anymore. We're dealing with tools, real money budgets, and serious safety concerns. So today, we're looking at a powerful, provider-neutral solution for Claude, Code, and Codex. It's called Agents Best Practices. We are going to unpack exactly how to tame those wild AI agents and bake some much-needed production-ready discipline right into your software. Okay, let's dive into this. The central tension of this entire project boils down to one big question. How can an agent actually execute tasks in real-world systems, like reading your databases, drafting emails, managing files, without turning into an unaudited operator that just runs wild? Because, look, if we just hand the keys over to a language model and say go, we are literally inviting chaos. We absolutely need a system of checks and balances. To solve that tension, we turn to this brilliant guiding philosophy straight from the Denis Circovich repository. It says, the model proposes actions. The harness validates, authorizes, executes, records, and returns observations. I want you to think of the model as the creative brain, right? It's coming up with ideas of what to do next. But the harness is the bouncer. It's this strict control plane that stands at the door, checks IDs, limits budgets, and ensures everything is strictly above board before a single action actually happens in the real world. So here is our roadmap for today. 1. Taming wild AI agents. 2. Model proposes, harness acts. 3. The best practices skill. 4. 3 ways to install. 5. Blueprints and harness audits. And finally, 6. Production-ready discipline. Let's get into it. Section 2, Model Proposes, Harnesses Acts, the separation of concerns. When you contrast a wild AI approach with a disciplined AI structure, the underlying flaw becomes super obvious. If you expect the model to police itself, you're going to fail. It's just that simple. The model is built to draft, to propose, to make suggestions based on its context. It's not built to enforce hard, unbreakable rules. That is the harness's job. The harness validates the schemas. It checks the permission labels, enforces time and cost budgets, and acts as the ultimate gatekeeper. Let's walk through exactly what this rigorous runtime journey looks like in a control plane loop. Step 1. The model proposes a tool use. Step 2. The harness steps in, validates that request, and makes a hard permission decision. Like, are we even allowed to do this? Step 3 is absolutely critical. It either executes the tool or it triggers an approval pause. This is where it literally pauses and waits for human intervention, like drafting an email but making you click send. And finally, step 4. It returns a structured observation back to the model, whether that's a success, a timeout, or a flat-out denial. This loop right here is the heartbeat of a disciplined agent. Moving to Section 3, the best practices skill, packaging institutional knowledge. So what is an agent skill exactly? Simply put, it's a static directory containing a skill.md activation document sitting alongside a references folder. But what that actually means in plain English is that it's a packaged artifact of institutional wisdom. When you install this, you are literally giving your Claude Code or Codex agent an entire library of best practices for harness design. It allows the agent to load structured guidance right into its context window the second you ask it for help. Now, it's crucial to understand the difference between this and an MCP server. An active model context protocol server is a running process. It exposes external tools dynamically at runtime. An agent skill, on the other hand, is entirely different. It is a static knowledge artifact. It doesn't actually run code. It shapes generation and design. Think of it as the architectural playbook your agent reads before it even starts trying to build those MCP servers and tools. And look, this isn't just some niche experimental idea. With 881 stars on GitHub and counting, this provider-neutral agent skill has very quickly become a battle-tested solution. It's fascinating to watch, honestly. Developers are flocking to it because injecting that production-level discipline into AI projects from scratch, that's incredibly difficult to do on your own. All right, Section 4, 3 ways to install, getting the skill. You basically have 3 distinct installation paths here. First, the traditional developer route, a simple command line global install using npx skills add with the G flag. That makes it so every project on your machine can discover it. Second, you could just manually clone the GitHub repositories straight into your user-level skills directory. But the third way? It's surprisingly meta. You can literally just prompt your AI. You paste a command telling your agent, hey, go clone the agent's best practices repository into my skills folder and verify the files. The agent will actually go out and install its own instruction manual. How cool is that? Regardless of how you choose to install it, you'll definitely want to run a quick verification. Just ensure these 3 items are sitting right there in your target path: the skl.md file, the icon JPG, and that vital references/directory containing all the markdown guides. Once you see those, you're good to go. You are ready to build. Section 5, Blueprints and Harness Audits, Real-World Scenarios. This perfectly illustrates the blueprint generation feature. Let's say you ask your agent to build an account renewal risk agent. Instead of spitting out vague, generic tips, the blueprint maps narrow, strictly typed tools directly to specific safety permissions. For instance, instead of a massive, broad write email tool, you get draft customer email, and that is explicitly tied to a draft external message permission label, which then forces a request approval gate. It designs the safety right into the architecture from day one. But what if you already have an agent and, well, it's a mess? Say you have a research agent that gets stuck running tools forever, burning cache infinitely, or it suffers from amnesia and forgets why it made a decision in the first place. You can actually ask the skill to audit your existing harness. It instantly identifies runtime-level root causes. It'll point out that you have no hard loop budgets, or it'll diagnose context compaction amnesia, which happens when your system compresses chat history to save tokens, but accidentally throws away the active human approvals the agent actually needs to proceed. Following the audit, the skill outputs a prioritized fix order. It tells you exactly what to do to cure those runaway AI headaches. Step 1. Add your loop budgets immediately. Step 2. Store those approvals outside the prompt so they actually survive memory wipes. Step 3. Rehydrate your active state during context compaction. And Step 4. Add targeted evaluations specifically for timeouts and budget exhaustion. It's not just a helpful checklist, it's a strict, step-by-step remediation plan. Finally, Section 6, Production-Ready Runtime Discipline, Beyond Coding. The incredible reach of this architecture extends way beyond just coding agents. Whether you are building agents for data research, customer support, financial analysis, legal workflows, healthcare, the rules of the game remain exactly the same. You absolutely cannot have an unaudited model making unilateral decisions in any of these high-stakes environments. Every single automated workflow requires the exact same core runtime discipline. I really want to hammer this main takeaway home. Budget enforcement, approval gates, structured observations, and maintaining a compaction-safe state. These aren't just neat little coding tricks. They are the fundamental pillars of reliable AI systems. By using the agent's best practices skill, you are baking safety, financial budgets, and human-in-the-loop gates right into the DNA of your product, regardless of whatever industry you happen to be serving. So I'll leave you with this question, and it's one you should probably ask yourself and your engineering teams today. Is your agent running wild, or is it a disciplined operator? I highly encourage you to audit your own AI harnesses, go grab the skill from GitHub, and start bringing some much-needed discipline to your agentic workflows. Thanks so much for joining me on this explainer, and happy, safe building.